All right, so the next thing we're going to do is figure out how we name compounds containing polyatomic ions. And it really is easy because the name of the polyatomic ion is half of the name of the whole compound. You just have to be able to recognize them. So I've got a flow chart here on how to name these things. You start off with writing the name of the metal, just like we always do. You want to write sodium chloride, magnesium phosphide, you start with the name of the metal, and you don't change anything about the name of the metal. You do have to, now that we've covered it, you do have to take a second and check to see if that metal makes more than one charge. And that's where you peek on the periodic table and say, is it one of these guys, group 1, group 2, or group 3? They only make one charge, so you can ignore this step. But if you look at these guys, remember in the middle, the D block and some of these elements over here, you actually have to look up to see, do they make more than one charge? Or do they just make one charge? Because if they make more than one charge, then multiple charges, then you have to add a Roman numeral. But if they only make one charge rather, if it's just one, then that's all you do. You just write the name of the metal and then you move on. Then you get to here. So the first word in the name, the metals always come first. Write the name of the metal. Don't change anything. Now, there's one exception. If the formula starts with NH4, you have to just recognize that. You have to know that's the formula for ammonium. And then you would just write ammonium at the beginning of the name. But if ammonium's not there, if it's any other metal, you just write the name of the metal. Magnesium, sodium, potassium, lead, whatever. You just have to take a peek to see, should I add a Roman numeral? And only add them if it's one of those guys that makes more than one charge. Now, the second word in the name. If the anion, is going back to what we learned already, if the anion, the nonmetal, is just a single element on the periodic table, well then just change the ending to "ide." So if it's just chlorine, you just change it to "ide," chloride, just like what we've been doing. But if the nonmetal, if the anion is a polyatomic ion, one of these groups up here, then you just write that name. You just write nitrate or carbonate or phosphate. You don't have to change anything. So if it's a single element, you change the ending to "ide." If it's one of these parties, one of these groups, we got sulfur hanging out with oxygen, carbon hanging out with oxygen, phosphorus hanging out with oxygen. If you have one of these polyatomic ions, you just say the name. So let's take a look at how this works. We've got sodium hooking up with nitrogen, N, just N. Yeah, we got 3 sodiums. Those are our cations, those are our metals, so we write sodium. That's our first step. And we have to take a peek to see if this metal makes more than one charge. If so, we write a Roman numeral. If not, we move on. So we look at our periodic table. Oops, where do we go here? Periodic table, here's sodium. Sodium's just making one charge. It's in group 1. It always makes a +1 charge. It's nice and easy for us. So we're going to skip the whole Roman numeral business. So, just sodium. Then we look at the nonmetal, and I see an N. Just an N. I don't see anything else. So I say it's sodium with plain old nitrogen. And the rule is, if it's a normal old element on the periodic table, like nitrogen is, you've got to change the ending to "ide." So this is going to be sodium nitride. This is what we learned and practiced in part 2, when we did the basic naming stuff. Sodium nitride, just plain little N there. Now over here, we have sodium in the beginning again, so we write sodium. We already know it only makes one charge. We don't need a Roman numeral. But then we say, who's sodium hooked up with? Well, it's bonded to NO3. This is one ion. You have to recognize it as one ion. There will never be something like sodium nitrogen oxide. We'll never have 3 things. That's crazy. We will have a positive and a negative ion. So if you decide sodium is the positive, which it is, then whatever's left is your anion, your negative charged ion. So this is a group. So you just have to look at your notes or look at the top of your periodic table and see what the name 4NO3 is. And it's nitrate. So you write nitrate. You don't change anything. You just write sodium nitrate. All right, the next one. We got calcium. Calcium's our positive metal. So we write calcium. But who's it bonded with? Well, if there's your positive cation, the rest is your negative. SO4. That's not just one little sad element. That is a group. The group SO4 called sulfate. So that's it. You just write the name. Sulfate. Now over here, we have calcium again. And we don't write a Roman numeral, by the way, for calcium, because if you look on the periodic table, calcium's over here. It's in group 2. It always makes a +2 charge. So there's no need to even consider Roman numerals for that one. But who's calcium bonded with? Calcium's our positive. Sulfur is our negative. That's plain old little sulfur. That's the element on the periodic table. What do we do with elements that are on the periodic table? We change the ending. So sulfide. So calcium sulfate, calcium sulfide. Look at the difference. All right, the next one. We got Mg. Yeah, there's 3 of them, but it doesn't matter. We just write magnesium. And we take a peek at our periodic table to see if magnesium is one of these crazy guys. Magnesium is not. It only makes a +2 charge. It doesn't have more than 1 charge in there. So we don't have to worry about Roman numerals. And then we say, who's it bonded with? So magnesium's the positive. Who's the anion, the negative? Well, it's just plain old P. I don't see any other element. And I certainly don't see a bunch of oxygens there. It's just boring old P from the periodic table. What do we do with elements from the periodic table? We change the ending to "ide." Phosphide. If you don't know how to do this, go back to part 2, naming basic ionic compounds. When you see phosphorus, you change it to phosphide. Just like we did in this example, potassium phosphide. We never use prefixes with ionic. I don't care if there's 3 here or 3,000. It would just be potassium and then phosphide. Plain old K, plain old P. So that's what we see over here. Plain old Mg, plain old P. Magnesium phosphide. But here, it's a little bit more interesting. We've got magnesium again, so we'll write magnesium. But then we have this crazy mess and another crazy mess, but they're the exact same thing. We don't care how many there are. We just know that this P has some oxygens with it. We call this phosphate. So this is a sign that it's not P by itself. It's P with some O's, and it's 4 O's for every 1 P. All right, over here. When you split this, and I knew to split it because I recognize this as ammonium and this as hydroxide. You might not recognize that yet. Obviously, it's red and blue. It's pretty easy to see. But you have to get in the habit of checking to see what your cation is. Typically, it's a metal, but every once in a while, you're going to come across this group, this ammonium group. So I write ammonium. And then, if that's my positive cation, what's this thing? Well, that's more than 1 atom. So it's not just 1 element on the periodic table. I have to go back to my groups here, and I look it up, and oh, that's my hydroxide ion. Hydroxide. So I write ammonium hydroxide. This one, I see ammonium again. I know it's NH4. That jumps out at me because I practice with these a lot. That's my positive guy. So I write ammonium. And then, if that's my positive, what's my negative? Oxygen. Plain old little oxygen. So I write oxide, because that's what I do with plain old little elements on the periodic table. Oxide. Now, let me bring your attention to this, please, please, please. Ammonium hydroxide ends with OH. Ammonium oxide ends in just O. They are different. Very different, even though they sound kind of the same. All right. So this is how we name them. Go through the formula, figure out what your metal is, write the name of the metal, check quick just to see if it makes more than one of these charges. We didn't come across any because I didn't put any of these crazy Roman numerals in here now, but you will see them when you do the practice. If there's only one charge, and in this case they were all just one charges, then we go down and move on into the anion. We decide if the anion is just one little element on the periodic table, or if it's one of these polyatomics, one of these groups, one of these, you could think P for polyatomic, P for party. Is it that element sulfur having a party with oxygens, hanging out with them? Is it carbon having a party with oxygens? Is it phosphorus hanging out with a bunch of O's? Think P, polyatomic, P, party. And if it's just a single element, change the ending to "ide." If it's a party, just state the name of it. You just have to recognize it.